Bismillah Rahman Rahim. As you know, we are discussing the oxidation of the chromium compounds, and today we will discuss a reduction of potassium dichromate, reduction of potassium dichromate K2 Cr2O7. Now potassium dichromate, in this case K2 Cr2O7, here it is in +6 oxidation state. So this can be reduced into chromium 3 and chromium 2 by treating with zinc along with HCl or sulfuric acid. Now the dichromate Cr2O7 -2, it is orange with oxidation state +6. Now when it is treated with the zinc and H ion, that is from the acid, it changes to chromium +3. This is green, this is orange, and oxidation state +3. Cr2 plus, it is blue, and oxidation state +2. This may be in the form water 2 plus, this may be in the form water 6 with +3 oxidation state. Now when we use zinc and treat it with HCl or any other acid, it produces zinc chloride plus H2. Now this hydrogen, since the flask is airtight, then this hydrogen will remain within the flask. So if we plug it with the glass wool, then the hydrogen will escape. So this is basically utilized to avoid the further oxidation back into the 3 or in the 6 oxidation state. So the reduction of potassium dichromate, that is, this is the potassium dichromate, this can be reduced into chromium 3 and chromium 2 when treated with H-zinc with HCl. So dichromate, orange in color with oxidation +6, when treated with the acidified zinc or zinc with HCl or with sulfuric acid, it is converted into the +3. It reduced basically. Here it is +6. The chromium, it is +6. So it reduces to +3 and then it reduces to +2. So this is in fact the reduction of potassium dichromate, and this can be shown by the experiment as well. If you have the titration flask, this is the titration flask, it is the glass wool, and here you have potassium, you have Cr2O7 2 minus, it is orange with chromium 6 oxidation state. So when it is treated with zinc with H ion or acid, then this can be represented by this, and here it is the color changes to green, it is green and is chromium with 3 oxidation state. So when this is treated with the under the same condition, then you have blue color, this is blue, and here it is chromium 2. So these can be represented by the experimentation or by the experiment that if you have potassium dichromate which is orange in color in a certain flask, then you uh, treat with the acidified zinc, it color changes from orange to green, that it reduces to chromium 3 oxidation state, and then uh, finally it reduces to chromium 2, which is blue in color as shown by the reactions as well. Now we will discuss potassium dichromate, that is K2Cr2O7, as an oxidizing agent. As oxidizing agent, potassium dichromate solution with acidified with sulfuric acid. Potassium dichromate solution acidified with sulfuric acid is usually used as an oxidizing agent in organic chemistry, etc. It is reasonably a strong oxidizing agent so that it can take the whole molecule into pieces. Similarly, potassium permanganate can also act as strong oxidizing agent. K2Cr2O7 is used to oxidize number 1 primary alcohols into aldehydes. This can be used to aldehydes, secondary alcohols into ketones, and primary alcohols into carboxylic acid. So the potassium dichromate solution acidified with sulfuric acid act as oxidizing agent, and it is used to oxidize primary alcohol to aldehydes, secondary alcohols into ketones, primary alcohols into carboxylic acids, CH3, CH2OH plus Cr2O7 2 minus plus 8H positive. Now when this is a ethanol is treated with potassium dichromate, this is basically oxidizing agent, and this is a ethanol. So when the ethyl alcohol or ethanol is treated with acidified potassium dichromate, this is in fact our oxidizing agent. It oxidizes the primary alcohol, that is ethanol, into ethanol or acetaldehyde. Now this is accompanied by that here the chromium plus 6 is changing to plus 3. So here itself it is going to reduce in the, so oxidizing agent in fact oxidizes others but itself is reduced, and this is shown by the change in color, that is the orange color is changed into green. So this will clarify the oxidation of alcohol into aldehyde. So we are having here the dichromate, that is orange, and it is going to change into green. So this is the oxidation of the ethanol. So potassium dichromate, in fact, when acidified with potassium dichromate, this solution, that is the acidified solution of potassium dichromate, this will act as oxidizing agent. So it oxidizes various compounds, especially it is used for the oxidation of various compounds in the organic chemistry. For example, it is used to oxidize the primary alcohol into aldehyde. If we take this primary alcohol, ethanol or any other primary alcohol, this is the acidified potassium dichromate, it is your oxidizing agent, it oxidizes this one into ethanol, and itself this chromium 6 orange in potassium dichromate, it itself reduces to chromium plus 3, which is shown by the change in the color. So by the change in the color, this is represented by the that how this is going to be oxidized. So it oxidizes primary alcohols into aldehydes. तो हम डिस्कस कर रहे थे कि किस तरह जो ये एसिडिफाइड पोटाशियम डाइक्रोमेट है ये किस तरह ऑक्सीडाइज करता है. ब्रीफली वी कैन डिस्क्राइब the above reaction as CH3 CH2 OH into CH3 CHO. So this is ethanol and this is ethanol. Now basically the oxidation of the aldehyde and some others, this depends upon the concentration of the ethanol. If the concentration of ethanol is not in excess and you distill off this ethanol, this is possible. But if the ethanol utilized in excess, that is CH3, CH2, OH, and you treat it with, you are going to oxidize, then this ethanoic acid will also be produced. This is ethanol, this is ethanoic acid. So ethanol is oxidized into the ethanoic acid, or this can be simply described as CH3 CH2OH plus Cr2O7 2 minus plus CH3 COOH plus 2Cr plus 3 plus water. Now this is again the whole oxidation, that is ethanol, and this is ethanoic. Now again you can represent that this is the chromium in 6 oxidation state, here it is chromium in 3 oxidation state. So this can also be represented by the, that how we can this oxidize. Similarly, if we have CH3, CH3OH, this is secondary alcohol, and we oxidize it into ketone, CH3, C double bond O, CH3. So this is a secondary alcohol and this is ketone. So we can also represent that this 2-propanol into acetone or dimethyl ketone. So by using potassium dichromate as an oxidizing agent, we can oxidize the primary alcohols into aldehyde if this alcohol is not in excess, and the ethanol or acetaldehyde produced is immediately distilled off, then you can have the one product. But if you are having the ethanol in excess like this one, then you will have the ethanoic acid, that this oxidation will carry on, and you will have also acetic acid or the carboxylic acid. And this is the equation for the whole oxidation, and this is for the secondary alcohols into the ketones. And this especially, these are the reactions which are utilized for the oxidation of compounds in organic chemistry. That is, alcohols can be oxidized, aldehydes can be oxidized, or the secondary alcohols can also be oxidized. Now we can also use potassium dichromate and oxidizing agents in titrations. In titrations, potassium dichromate is a powerful oxidizing agent, and this power, this ability is represented by the reaction, that is K2Cr2O7 plus 4H2SO4 gives K2SO4 plus Cr2SO4 whole thrice plus water plus oxidation. Now, this is basically that how it is used as an oxidizing agent, that the potassium dichromate, this is acidified potassium dichromate, is represented how that it act as an oxidizing agent. In terms of electronic concept, the K2Cr2 takes electrons and get reduced itself, that is Cr2O7 2 minus plus 14H positive plus 6 electron gives 2Cr plus 3 plus 7H2O. Now here the chromium is in plus 6 oxidation state, and here it is in plus 3 oxidation state. Its color is orange and this is green. So it basically represents the change of chromium in plus 6 oxidation state into plus 3 oxidation state. Potassium dichromate K2Cr2O7, it is non-hygroscopic and primary standard. That is, this one is very important over here, that why the potassium dichromate, that this is used as oxidizing agent. Sodium dichromate is also an oxidizing agent, and other F salts are also oxidizing agent. But why we select potassium dichromate as an oxidizing agent? Because it is non-hygroscopic, that it does not absorb moisture and thus can be utilized as used as primary standard, that its strength remains not affected. Now, the reaction with potassium iodide, K2Cr2O7 plus H2SO4 plus Ki, K2SO4 Cr2SO4 whole thrice plus water plus I2. Now, this is the redox reaction, that how we can utilize the power of potassium dichromate as an oxidizing agent in titration, especially. The one reaction is reaction number 1, that is the reaction with potassium iodide. Now here it is in plus 6 oxidation state. Here it is in plus 3 oxidation state. Similarly, this is minus 1 and here it is 0. So you can simply say that the chromium Cr2O7, the chromium plus 6 oxidation state is converted into plus 3 oxidation state by taking 6 electrons. So this is our oxidizing agent. This is oxidizing agent. So this is going to reduce from orange color to green. So it itself reduces, whereas the iodide ion oxidizes into iodine with this is oxidation. Said it is oxidizing iodide ion into iodine molecule. So here it is going to be oxidized. This is going to reduce. This is colorless and this is colored. An ionic equation can be written as Cr2O7 2 minus plus 14H positive plus 6 electron gives to 2Cr plus 3 plus 6I negative plus 3I 2 plus 1. Now this is basically the ionic equation that the iodide ion is changing into this 0, and here it is plus 6. So this can be represented by the ionic equation. Now the reaction 2, a reaction with FeSO4. Now the K2SO4, K2Cr2O7 oxidizes Fe plus 2 into Fe plus 3 in the presence of H2SO4 and represented by an equation K2Cr2O7 plus FeSO4 plus H2SO4 gives Fe2SO4 whole thrice K2SO4 Cr2SO4 thrice plus what? Now here the chromium is plus 6, here it is plus 3, this is plus 2 and this is plus 3. Now the chromium plus 6 is reduced into chromium plus 3, whereas as oxidizing agent it oxidizes this reducing agent. The ferrous ions, they are converted into ferric ion. So the ionic equation can be represented as Cr2O7 2 minus plus 6 Fe2 plus plus 14H positive 6 Fe plus 3 plus 2R Cr plus 3. This is the ionic equation. Here it is plus 6, here it is plus 3, and this is plus 2 is changing into the plus 3. So this is an ionic equation which is represented by the. So what will happen? Because in case of iodide titration, or in this case, in case of ferrous sulfate, this is light green in color and this is brown in color. So the green color changes into brown. That is the, you can guess from the change in color. Now similarly we can also utilize for the oxidation as well in case of organic compounds, as well as we have shown in this reaction. So this was all about the potassium dichromate as an oxidizing agent in the organic chemistry, and in this case, in case of titration, here the Cr6 reduces to Cr3 and Fe plus 2 get oxidized into the plus 3. So this was all about the titration, that how we can use the potassium dichromate as an oxidizing agent. तो इंशाल्लाह नेक्स्ट हम डिस्कस करेंगे. टिल देन अल्लाह हाफिज़, अस्सलाम वालेकुम.